All right, here we go again. So it says that phosphates are used as commercial fertilizers to reduce possible toxicity. Calcium is the cation used. So I'm obviously reacting something. I got something calcium reacting with something phosphate. We're just trying to translate this problem into something I can actually solve. In an industrial test, 3 molar sodium phosphate, so 250 mils of it, and a 2.5 molar calcium nitrate, 300 mils of it, are mixed. So this is going to be some solution chemistry, solution stoich. What mass of fertilizer is collected? Well, that's pretty straightforward. Just find amount of solid product. So we're going to do some solution stoich with this stuff here. Since phosphate is considered a pollutant, solutions exceeding 0.5 molar can't be poured down the drain. How should the supernatant be disposed? So that again sounds like a solution stoich kind of calculation. I need to know whether or not there is that capping amount of phosphate in my solution. If there's less than this, I can pour it down the drain. If there's more than that, I can't. Again, I have no idea what the EPA's standards are for disposal. I don't pour anything with phosphates in it down the drain. These are all just numbers I made up for this problem. So since this is solution stoich, let's get to it. The last thing I need is somebody coming after me for saying the wrong amounts. I don't know, disclaimer, this is just a problem that I made up. All right, so we said we had these two things reacting, sodium phosphate, calcium nitrate, and there's that phosphate as promised. So it's my phosphate and my calcium that are creating my solid. So I need to know, do some good old-fashioned solution stoich, how much solid product that I make. I skipped the path, quote-unquote, on these. I hope by now you're familiar enough with solution stoich problems that you don't need it. But if not, feel free to write out that milliliters to liters to molar, whatever, thing to help you with the bookkeeping. So in this one, you'll notice I accidentally got these mixed up, but that's okay. So I know I had 3 molar sodium phosphate. I had 250 mils of it. Mils, not so good. Converted to liters. Converted between moles of my reactant and moles of my product here. Convert to grams. Ta-da! Again with the solution stoich. This time I did it in the right order. So 300 mils of my calcium nitrate solution. Don't like mils. Convert to liters. It was a 0.25 solution of the calcium nitrate. Convert from reactant to product. Formula mass gives me my mass of solid product created. Notice this is the smaller number than this one up here. Means my calcium in my calcium nitrate ran out before I could make this much product. Means my phosphate is in fact in excess. So there will be some extra phosphate ions floating around in that solution. So I have successfully answered the first part of my problem. 77.5 grams of calcium phosphate of our fertilizer will be recovered in this reaction. But now I need to know what to do with the supernatant. Remember, the supernatant is the solution on top of our beaker. Our solids at the bottom, and then our liquid on top is called the supernatant. Super means above. So, in order to figure out how much phosphate I actually used, I take my 77.5 grams of my solid product that I created, and I convert it to moles, and then I look at this formula. Per 1 mole of this, I have 2 moles of my phosphate. Tells me that I used 0.4998 moles of my phosphate to make this amount of calcium phosphate. But I need to know how much are left in my solution. Means I need to know how many I started with. Since my phosphate came from my sodium phosphate solution, that's where I'm going to begin, with my 250 mils of that sodium phosphate solution. Don't like mils, convert to liters. It was a 3 molar solution. Now we're going to look at that substance again. Sodium phosphate, if you look up here, per every 1 sodium phosphate molecule, you have 1 phosphate ion. So that's the 1-to-1 thing here. Tells me I had 0.75 moles to start with. So if I started with 0.75, I used up about 0.5 of them. That tells me I have 0.2502 moles left. Since I want to know the molarity, I have to divide this by the total volume. So we mixed together 300 mils of calcium nitrate, 250 mils of sodium phosphate. I added those together and converted them to liters to get this number. So moles divided by liters gives me 0.45 molar phosphate solution, which is less than my capping 0.5 molar phosphate solution, so that means this one can safely be poured down the drain. So once again, this is an example of how our solution chemistry, our solution stoich and excess reagent calculations can be used in a slightly more practical means to calculate something. So I hope that makes sense. Best of luck in your story type problems in the future.